Alrighty. I think we're good. Down a little bit. Alrighty. Let's see. Try to get this like we can all read it. That'll probably be good for now. Okay. Alrighty. So I've touched Rust a little bit, a little bit. So I'm gonna skip over like the Hello World stuff because like I've done this stuff before. But actually like writing the code, not not a lot. I think I got about as far as like the ownership and borrowing, and then just kind of lost my mind. So we're gonna see how well it goes this time. So I'm gonna start here. So for anyone that doesn't know what Rust is, it's a pretty popular, I guess, and kind of contentious language. It's very, very expressive. It's very, very powerful in being able to represent and guarantee sort of correctness in your code. So it has guarantees about like if you have an enum where that you write a switch statement on, it'll make sure that you have to enumerate over every possible enum in order for it to be considered valid. It makes sure that all of your types are super secure. It is a really good advanced type system, so it pulled that in from like functional languages, so you can make compositive. It's like what additive and multiplicative types, I think. Like so, basically like enums and structs. It has the trait system, so it's similar to like interfaces in other languages, but not quite. And it's very famous for having a pretty steep learning curve. Um, Even with all the great documentation around it, the great tutorials around it, just a very steep learning curve because it requires you to have a lot more, just a lot more in your head than I think a lot of other languages. It requires you to really think about every piece of your program. But in the end, the mantra that I've seen over and over again is when it compiles, it'll be great. You just have to get it to compile. So that's what we're gonna start with today. So let's see, cargo new guessing game. Cool. Add my main Rust file. Yep, make a new module, and then I get this guessing game version 010 edition 2021. New generates all this stuff. Then I can do cargo run. I need to be cargo run. And it says hello world. Cool. So what's next? Sorry about that. Every about 30 seconds, I'm gonna have to reach down and throw this toy because she just absolutely loves playing with her bone. So she'll lay down for like, I don't know, a minute. And then she'll kind of wander back over here. Let me see if I can, so you guys can see how I work. Yeah, so here she comes. And then she drops it in front of me. Gotta reach over. And throw it up. And she catches it. It's a good trick she's got. Anyway. So yeah, cargo.toml holds dependencies and, metadata, all that kind of stuff. So let's go into this. Using standard IO package. Println exclamation point. Let's see. Hello? Hello? Okay. Give me 1 sec, and I'll get this fixed. Alright, I think that's working. Yes, it is. Okay. Put that about there. There. And we're back. Okay. Sorry about that. Mic unplugged and it just was not happy about it. So, guess the number. So that should be like print and then new line, right? Sure I have like the Rust stuff. Okay. So yeah, I have that installed. What does this give me? Just analyzer, even better TOML. Yeah, we'll install that because it'll make it work a little better. Okay. So print out that. Print input guess. So let mutable variable guess is a string, and then io std in dot. Why am I not getting? Hold on. Why am I not getting syntax highlighting? The Rust analyzer instead. So it knows, hold on. It knows that it's there. It knows that it's Rust analyzer. Cannot find proc macro. Oh, is it because I need to do it this way? No, it still doesn't know how to do it. Is Rust src installed? Oh, it's because I don't have the. Hold on. I need to get off of Nix. It's really screwing up a lot of my, like, the way that things work. And I really don't feel like toggling all that stuff. 1 moment. So that should get everything actually installed so that I don't have any more of these issues. So now I should be able to do Hold on. I see. Okay, so Vim. Fish, add path. Virgo slash Andy, right? Alright, I need a source. I have add bin to my path. Yeah, it just adds the bin, okay. There we go. Now I should be able to do go to repos, Rustbook. There we go. Okay. Back to what I was doing. I want read line, which takes in the buffer, which is a mutable reference to a string. So make a mutable reference to my guess variable, and then expect failed to read line. Okay. So, what? Okay, so this, right, results, that was a thing. This function may panic. It is generally discouraged. Instead, prefer to use the pattern matching and handle the error case explicitly, or call unwrap or unwrap else or unwrap defaults. Okay, so this is, I guess, the Go equivalent of if error not equal to nil, panic. Does that sound like that? That sounds about right. Okay, I failed to read line. Cool. And then I can do another print ln. You guessed. Yes. I do like that all strings are essentially template strings. It's like if I do that, I'm assuming unknown character escape. What if I just want to... I'm not going to worry about that right now, but... Oh. If I did that and that. So... Okay, I don't understand how I would type just a bracket, but we'll take it. So, right, importing from the standard library. Finding the standard, bringing the scope of every program. This is called the prelude. In the standard library documentation, cool. If a type you want to use isn't in the prelude, then you have to bring the type into scope explicitly with the use statement. So using stdio. So I guess I could do that. Okay, so it's the same as C++ uses. It just means you don't have to specify the... It just means you don't have to specify the namespace. Okay. I have a main function. Yep, print statements is the macro, and I'm sure I'm gonna get into macros at some point and just be utterly confused, but we'll get there. See it, instantiate a new string. I've also seen that there are like 17 different ways of doing strings. So I'm terrified of, like, I've heard Rust has like super great like string manipulation, but there's also 20 different ways to do a string. So I'm sure I'll get to that, but eventually. So let's see. Program's getting interesting. Log on this line. We use the let statement to create a variable. New variable name binds to the +5. Variables are immutable by default. Right, that was the other tricky bit. Meaning once we get the variable value, the value won't change. We'll be discussing this concept, and yeah, later on, we add the mut or mute before the variable name. Cool. Equal sign to you want to bind to something. Guess is bound to results as a new string. And is a growable UTF-8 encoded bit of text. Right. Indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type. Creates a new empty string. Call the name. So that's like, I guess the idea of like a static function. I mean, I don't know a lot of like there's a lot of very functional ideas that Rust has with its type system. So like, I'm assuming that an associated function, like when it says it's implemented on a type, it means that it's like a static function, I guess. Right. From the standard library, we call this stdin, let's just do that. If we hadn't imported it, yeah, we could do that. Calls the readLine method, parsing, right. Read the line, store it in this buffer. Indicates that it's a reference. References more thoroughly, right? We're still working on this line of code. So like if I just deleted this, if I deleted this little line and just ended it. Okay, it would give me a warning. Got it. Yeah, I'm interested. Okay, so I'm expecting... Right, so that's just the if panic. Always introduce a new line or other white space to open up. Read line puts whatever it is. Is it an enumeration, right? Result variants are OK and error. Indicates the operation was successful, and inside the OK is the successfully generated value. The error variant means the operation failed, contains information about how it failed. Okay. An instance of result has an expect method that you can call. If this instance of result is an error value, expect will cause the program to crash and display a message. So you'll get a warning, right? Which you learn how to do it properly way later. Cool. This line prints the string and now contains the user's input. The set of brackets is a placeholder as little crab pincers, right? When printing the result of evaluating expression, we do that. Okay. So yeah, we can do test the first part. 6. Yeah, 6. Cool. Generate a secret number that the user will try to guess. Should be different every time. So we'll use the rand crate. Remember when a crate is a collection of REST source files, right? As a library crate which contains code that is intended for all that, blah, blah, blah. FileName cargo toml. Right, so I go in here. 0.8.5. Right. Cargo build, which will download the random number stuff. Got it. Okay. Right. Using the cargo build, make sure you include the lock file, right? All right. Okay. And you do want to update a crate, reprise the command update, which will ignore the cargo log file. Alright, so we do cargo update. Okay, but it hasn't. That's just the version. Cool. Alright, back to the code. So we'll use rand RNG to then up at the top, secret number rand thread random dot gen range. Okay, that one's so range R is a sample range. Okay, that just means inclusive range. Got it. So it can return anything, I guess, based on the type here. That's pretty impressive. Right, the use gives us the particular random number generator we're going to use, one that is local to the current thread of execution and is seeded by the operating system. Then we call the genRange method to generate a number, defined by the RNG trait that we brought into scope using that statement. The genRange method takes a range expression as an argument and generates a random number in the range. And a range expression here takes the form start ... equals end, is inclusive. You won't just know which traits to use and which methods and functions are called from a crate, so each crate has documentation. A neat feature is opening the docs. Okay, so I have to know that this is something I have to import. So like if I do that, it won't know what the hell that means. So wait, so you can bring, you have structs, so like this thread RNG, and then you can bring specific traits into scope? Items from traits can only be used if the trait is in scope. Huh. That's interesting. Alright. Okay, so now I've got all this stuff, so I guess that. So let's see what the got compare to secret number, ordering less, too small, when too big. Right. What does this do? Right, but it's going to compare it by strings. Made of arms. An arm consists of a pattern to match against, and the code that should be run if the value given to match fits that arm's pattern. Patterns in the map are powerful ROS features. They list express providers should encounter them. Yeah, they'll be walked through later. Mismatch types. For strong type system, however, it also has type inference. When we wrote this, was able to infer that it was a string, a number. Right, a bunch of different numbers. We want to convert to this string. The program reads as input into a real number, so we can compare it numerically by adding this line. Just this, right, and then trim.parse.expect. Please type number. So that's already has, it does hopefully allows us to shadow the previous variable value with a new one. Lets us reuse the guest variable name rather than forcing us to create two unique variables. So I guess it knows that as soon as... I guess it knows that, like, as soon as this executes, this guess goes out of scope, and they said they'll do more about it later, but that feels like it's bad. I don't know if I like that. Convert string to another type. To convert to string to number, we need to tell the exact number type by specifying that. We'll use U32 here, perfect. So yeah, it might fail. Okay, so we'll say Run the program a few times to verify different behavior. Cool. Let's print line. Secret number. Oop. That's it, just oop. Interesting. Okay. Quitting after correct guess. So yeah, so if it's equal. Cool. Let's see. Okay, interesting. So if I take this parse, 52 equals match. So I can just return a value out of this thing. I can say, okay, num, error, continue. Interesting. Like, yeah, it'll just ask me again. Cool. So let's do that. Cool, so like 33, too big, 12, 25, 20, 23, 4, there we go. Cool. How they work in Rust, have much in common. So yeah, none of this is variables, immutability. Cool. Cargo new variables. All right, so it's let x equal 5, int value is x equals 6. Value is Right, because it's immutable. That needs to be immutable in order for it to change. Okay. Constants are values that are bound to a name and not allowed to change. You aren't allowed to use mute with constants. Aren't just immutable by default, they're always immutable. And the data types must be annotated. May only be set to a constant expression, not of the result of the value that could be computed at runtime. Okay. Okay, shadowing, yes. You can declare a new variable with the same name as the previous variable. Stations say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any uses of the variable name to itself until either it itself is overshadowed or the scope ends. We can shadow a variable using the same name and repeating the use of the word let. Okay. That's interesting. Let x equal 5. Let x equal x plus 1. Let x equal x times 2. Value in inner scope. Value of x is oh, that's interesting. So this gets shadowed only in this scope. That's interesting. So we'll get a compile time error if we accidentally try to reassign this variable without using like. We can perform a few transformations on a value, but have the variable be immutable after those transformations are complete. Okay, it feels like a very subtle difference, but I guess the other benefit is that you can keep that kind of in scope, right? So like if I need to only for a specific scope need to like declare something, right? I can shadow it for a scope, set that thing up, and then let it come back. Right, but you can't manipulate that. So there's data types. These data types, there are scalar and compound. Right. We'll display the following errors, means it needs more information. Right, these are primitive types, you know, integers, floats, booleans, characters, right? Yeah, integers, they've got a whole bunch of sizes and yeah, literals can be doing all that. If you try to change the variable, blah, 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 overflow occur. Rust includes checks for integer overflow that cause your program to panic at runtime if this behavior occurs. Does not include these checks. So it can integer overflow. Okay. Right, floating points. Supports all the basic math. Boolean. Goes perimeter alphabetic character, right, as a Z. Right, compound types are the interesting ones. do you need me to do, Suki? What do you need to do? She just loves jumping. I don't know. So, right, tuples. Fixed length, they cannot grow or shrink, which is a comma-separated typed list of things. Combined into a single element. Use pattern matching 2D structure tuple like that. Right. I can do like so I guess that's how you do like multiple returns. Like if you wanted to, you could return a tuple of something. Okay, you can also just index into them like that. Array types. So arrays are unlike a tuple, right, must be the same type. Fixed length on the stack rather than the heap, right? Where you want to ensure that you always have a fixed number of elements. If you're unsure of that, and you know the length, right? Ugh. So it'll panic. Need them to access all that, running index. Right, okay. Functions. Alright. You gotta chill. Okay, go lay down. Oh. Hey man, thanks for the follow. So let's see. Snake case, okay. So it uses snake case for convention, make other functions. Oh, thanks for the follow. So we define a function in Rust by entering all this stuff. We can call any function we define by entering its name, followed by print. Yeah, just like most of the programming languages. Yep, parameters. That sounds about right. Must declare the type of each parameter, right? Makes sense. A series of statements optionally ending in an expression. Oh, okay, this is like the functional stuff that I always dislike. Functions you cover have included an ending expression, but you have seen an expression as a part of a statement. Because Rust is an expression-based language, it's an important distinction, okay? So statements are instructions that perform some action but do not return a value. Expressions evaluate to a resultant value. We've already used statements in expression, created a variable and assigned a value. So let y equal 6 is a statement, right? Statements don't return value, so you couldn't assign that. Yeah, I do really like Go. It's why I kind of use it as my like main language, just because I can just be that productive in it. And yeah, it's just, it does feel really, really good, but I do want to, I'm trying to like see some of these other languages. I've heard a lot of good things about Rust. I've heard a lot of not great things about Rust. So I'm trying to see if its type system is better or not. Ah, nice, man. I've heard a lot of people really like Rust for game dev. Like, there's a lot of good game engines. I think Bevy is the one that I know of that people really, really like for it, because they've been able to kind of make it work really, really well within Rust, like, because they can do all like the macros and all the cool syntax stuff, so they can make like really, really cool, like really focused stuff for it. Yeah, and I think it'll end up. I think I'm gonna like Rust for really, really specific things. Like, if I need to do like really, I don't know, I feel like I really want my Rust project, like right now, I feel like Rust is good for like small services. Because I work primarily with like web services and Kubernetes and that kind of stuff. And I feel like smaller services work perfectly. Oh yeah, no, my degree was in embedded, yeah, was it embedded systems? I think was the concentration. So I know exactly what you're saying with like the nightmare that is C and C++ in those kind of like advanced use cases. They are really, really, really painful. There's a couple of really good things for it, like templating engines. There's a couple really good ones. Everyone loves to rave about like Rust WebAssembly and stuff like that. So we'll see how well it works out. I know it can handle like, it's really good for, there's a bunch of different like use cases, like Discord and Cloudflare I think are like the big case studies where they were able to take kind of a small service that does like deduplication or like firewall rule checking and stuff like that, and they turned it from whatever they had before into Rust, and it worked like magically. So I think that's where I'm gonna try to like focus, and I think CLI tools people have been saying Rust is really good for as well, because it just does like its string manipulation super, super well. Let's see. Yeah, this is the stuff about Rust that I'm not sure if I like or not. I don't know how much I like doing this like naked return. Cause like you can do like if I just, you know, this returns I32, sure. Because you can just do like 5 and that works. I don't like that. I would much prefer using that. Like that, I know it doesn't make a difference, but it hurts me. I know you can use the return. This has always messed me up. I get that it's like expressions and all that, but I really, really just prefer like the return. And I know that's like it's a thing from like functional like I think it's from Haskell. It's like where the inspiration came from, but ugh. Yeah. Oh, I think what's the thing for it, like Rust string types? There's like I think how many is there? There's like, yeah, this is every string type that there is. Like 22 minutes on every single way that you can declare a string. And that is my like one gripe with Rust, is just pick away, please. This is all fine. Like, what I in my ideal world, I would want to take, like, the Rust type system and put that into, like, Go. Because I think it has a much better... I think it has a much better type system with being able to, like, pattern matching and, like being able to pattern match on enums is amazing. Like, if I could just get that in Go, I'd be very happy. Yeah, this is all else if. Yeah, if let, which is pretty nice. But yeah, I know what you're saying. The Rust solves syntax problems the same way that C++ does, which is just add another language feature. And that's not, I don't think that's always the best way, because you just pack like so many layers on top of layers on top of layers, it becomes impossible. Like, if you happen to use this one abstraction slightly wrong, or because you don't really know the difference, you get this horrific, like, pile of bugs that you have to go run through forums and try to find the one guy who remembers how it actually works under the hood. Provide several, of course they provide several loops. Like, why? Yeah. Yeah, I think there is, like, my like primary, I have two like main things that I like judge a language on, and it's like once I get good at it, right? Like, because every language is going to have some learning curve, some new way of thinking about it, you know. So that's, I more or less discount it because that's like a one-time cost kind of thing. So once I know the language, right, how productive can I be in it? How fast can I create the things that I want to create well? You know, not just like ignoring all the errors and just going straight forward and, you know, scripting the hell out of it. And then B is how it's basically like, how easy is it? And it's hard to describe, but like, nope, that was the wrong button. I am so sorry. Hold on. Where's the mod tools? There is. Actions. Undo that. Sorry about that. Yeah, I went over to like click on something in OBS and it like hovered over it. Alright. But yeah, like my main like thing is like, alright, once I know this language, how well can I execute the things that I want to do? And then how easy is it for me to like get other people on board into the project, right? Like, do I need to sit down and give them like a full, like, you know, several hour session to get them into it? Or can I say, you know, can I hand them the code and a couple comments, a little bit of documentation, and they can kind of take it from there? So like, for me, Golang fills like 99% of that. Like, I can, anybody that knows Golang, I can pretty much drop them in a project and they can pretty much figure out what's going on 99% of the time. But then something like Rust or C++ or like these languages that have like 1,000 ways of doing something, even if you know the language really well, you may not have encountered that way of doing something, or, you know, seen, or that's a new way of looking at it, or whatever it is. And even then, you have to have someone sit down and explain to you, okay, this is why we're doing this is what we're doing, we're using these features, not these features, do this, not that. And so like that's why I have like I have a love-hate relationship with Python, because that to me is like the biggest, like, it doesn't matter how much Python you know, every single Python project you look at might as well be its own language. Hold on. So. That's interesting. Let result equal loop. Huh. Yeah. It definitely, like every language has a learning curve of, like, you can't just take the same methodology and just kind of pick it up and put it back down. And yeah, once you kind of get used to that, yeah, Go definitely uses pointers as its like catch-all, which I appreciate in that language. But yeah, there's definitely better when you have more access to memory and more access to do things cleaner. Definitely a lot of better things to do. Right, loops within loops, they have loop. Oh, interesting. Okay. Conditional loops with while, looping through a collection with for, yeah. Like, that's all pretty straightforward. Okay, they do have in, so that's kind of nice. I think the last time I tried to learn Rust, I got caught up in, like, unwrap hell. Of just, like, every single function I called, I had to unwrap and then do something with, and then unwrap it again, and I was like, you know what, I'll just keep, I'll just keep using Go. It's working great for me. Let's see. Regularly looks for no use memory. Okay, free the memory. Interesting. Right, the stack and the heap. So let's see. Parts of memories, user CRUD time. Yeah, heap is less organized. It has memory, yeah, just random pointers. Yeah, it definitely has the biggest, like, change of mindset to go from one language to another. Like, you really have to learn how they're expecting things to kind of run, right? Right. Yeah, There are a lot of there are a lot of things I think once you learn Rust, because it like the compiler basically forces you to write things in a way that it's really, really hard for it to really panic or fail. So I think once you kind of get in those habits, you do start to break them over and try to use them elsewhere. So yeah, we'll see how it is. It'll be an interesting journey. I did also want to try Zig because I've heard that it's closer to like C syntax wise, but just like better, I guess. So we'll see. Maybe after I get used to Rust and build a few things in it, I'll try Zig. Yeah, it's not ready for like I wouldn't put a production system on it that I actually have to like rely on, but it'd be interesting to see like what they do. Right, only one owner at a time. Yeah. Yeah, that's not really good for like actual systems. You can't have breaking changes every 2 months. Let's see. Oh, cool. Yeah, I'll have to check them out. There's that. This is the part where I'm really gotta try and wrap my head around it, because like I get it in principle. It's just always when I go to start writing stuff, the borrow checker kills me. Because it's not declared, right? Valid from this point forward, so the scope's over, S is no longer valid, right. Like that part, totally fine. And then, where's the string that relate to ownership? We've seen string literals where string values are hard-coded. They aren't suitable for every situation. They're immutable, right? The double colon operator allows us to use from, right? This kind of string can be mutated. Pens, right? Do you have say they made all variables declared as mutable. Oh, so if you declared it as mutable but you didn't actually mutate it. Yeah, I like the stuff that I'm seeing from Zig. I haven't like written a good amount of code in it, but like the things that I've always heard is like the language has a really good solid base, but it needs better tooling, and it needs to stop pushing breaking changes. Right. Yeah. That is the nice part, is like when you can jump into a project and like just knowing the language, you can read it all. Yeah, Go definitely has the same feeling to it. It's kind of a similar thing of like you can write Go in like 1,000 different ways, but there are definitely ways that once you figure out like the Go way to do it, it feels really good and it feels correct. So you tend to do it a lot more. So like they do a lot of dependency injections into structs. So you can really follow that chain down. And it makes it really, really easy to follow, like, because there's not like 1,000 different ways, especially, yeah, with not having 1,000 ways to do things. It's like, oh, I know what that is. I know what that is. I know how these things work. So I can jump into most projects and be able to contribute something meaningful in a couple hours. You know, take some time, read the code, figure out what it needs to do, and just start going. Rustlings? No, what is that? Oh, cool. Interesting. Yeah, let's try this. So is this a... Are sorted by topic, found in the subdirectory. Okay, interesting. So yeah, let's try that. I think that'll be much more interesting. Let's install that. I probably wanted to clone that somewhere else. Let's see. Nice, yeah, let's try that. So yeah, let me do this. Because that'll be much more interesting than just, you know, reading through the book. For probably some of the more... I mean, I haven't tried it, but we'll see. Okay. Sorted into topic, found in the subdirectory. For every topic, there's an additional README file. Recommend you get them look before you start. Okay. Keeps them from compiling. Some exercises are also run as tests. In the recommended order, alright. Rustlings watch. Okay. Let's see. Yeah, it's a really good, like, from the beginning. Like it's good for, I'd say it's good for new-ish programmers. Because I feel like if you have programming experience, it's too easy. Yeah, I really like the by example stuff. But I feel like if you're a new programmer, like the Rust book is almost too high and too much detail to really understand it. And if you know programming, it's too much repeated unnecessary detail. So it's in a weird spot for me. Same. Oh, cool. So let's exercises it wants. Intro 1. Or about this, we sometimes encourage you to keep trying things. Let's see. I'll actually run this in here. It'll be easier. Okay. If you're running this, the exercise file will be reloaded when you change the lines below. Try adding a print line or changing what outputs. Try moving a semicolon, see what happens. For a semicolon. Okay, cool. By removing the I am not done comment. Okay, that's cool. I really like that. Make the code print a greeting to the world. Alright, so this is just... Cool. Yeah, this is awesome. So this is now... variables. Right, make me compile. Cool. It's 2. Assuming, yeah. So make it compile. Let x equal something. And it's also not initialized. Alright, so I can just do... Cool. I wonder if there are like versions of this for other programming languages, because I would love to be able to give something like this for like TypeScript or Python or Go or something like that to someone. And just be like, hey, here's this, run through it. When you get through it, you'll know what you're doing. Ziglings, nice. So there's like... Cool. Okay, so it moved to that. Okay, cool. I'm gonna keep that in my back pocket because I actually have to... I'm trying to onboard a bunch of, at my job, I'm trying to get a bunch of, the engineers that currently only know Python to try and learn Go, so that we can start migrating a lot of some of our services from running like centuries-old Python into Go, because they are struggling to scale. And that, I think, is going to be one of the like best ways for them to learn. I really do like hands-on learning. I usually find the best way is, the best way that I learn is through like projects. But something like this is like the perfect way to like get started. So don't change this line. Yeah. Okay. Yeah, that you can see like this progress bar really does help. What? 3, spell a number. Alright, so just... Yeah, shadowing. I do like this though, like if I hadn't... I feel like you need some context from the book though. Because like, especially with like this one, if you didn't know shadowing was a thing, this would feel impossible. Like, I can't change this line and I can't rename the variable, it's impossible. It's like, you might need like the basic, like up to chapter like 3 for just like basic syntax stuff, and then you can kind of jump into it. Yeah, provide a type for the constant, yeah. Perfect. Oh, it has like, it's got hints, right? Cool. Okay. Then yeah, that would definitely help. Is that the thing that I've been like skipping with this readme? Yeah, okay. I've just been skipping it. That'd be why. I've just literally just been skipping. So I just need to make a function. Yeah. It doesn't sort of make you go through all the different sections and like, all right, read through all this and do all that. You can just kind of roll through it pretty quick. Let's see. Yeah, because these are, like, I like these as, especially with getting used to, like, reading the compiler messages. Outside of just using, like, the IntelliSense stuff. So it really, like, helps you get used to it. Let's see. Square from This is pretty good. If. Same. Oh, yeah. I do very much appreciate, like, I do appreciate Rust that, like, once you get it, it's awesome. It just takes a hot minute to really get. To return the big number. Cool. Do like I could do that as well, right? I do like this though. I kind of like this inline if thing. I can see it biting me later down the line, but I kind of like it. So same. Get the bar for fuzz and default to Baz. So it should return bar by default. Right? Oh, okay. If it's buzz, it should be bar. Anything else is Baz. Got it. Else. Bizish equal to buzz. Bar Baz. There we go. Okay. 3. Else if incompatible types. Right, some static string. So, animal habitat. Okay, I see. So let's do 2. So wait, let identifier equal, right. There we go. Quiz 1. Price of the apples is calculated as follow. If Mary buys more than 40 apples, calculates the price. Okay. Mounts. Right. So return if amount greater than 40. Amount. Else amount times 2. It is very, very clever. Let's see. Primitive types. So let's see. If is evening. Like the example, or make it be false. Let right, so that's just primitive booleans. Finish the line like the example. What's your favorite character? There we go. Yeah, it feels fine. Create an array with at least 100 elements where the question mark is. Huh. It'll probably, yeah, I'll probably try to speed run through all this. Oh, isn't there a way to do like, isn't there a way to do like initializing arrays with like large amounts of elements? It's like just array range, something like that. Yeah, there we go. That's what I'm looking for. So yeah, it's gonna be I32, 100. Perfect. I'm seeing some interesting stuff here, like the smart pointers, iterators. Lifetimes is gonna be like lifetimes and macros are gonna be fun. I don't know how much I'm gonna get through on this stream. I'll probably go for like another hour, and hopefully I can get to something interesting. I'm assuming slices kind of work the same way, where you do like a reference to A, like tip 1 4. Yeah. Yeah, starting at index 1, 2, 3, 4, not inclusive. Your pattern here. Destructure the cat so that the print line work. Oh, okay, yeah. Cool. Use a tuple index to access the second array. You can put the expression for the second element there. Is it numbers dot one, right? Cool. There we go. Next, vectors. So let's see. Make me compile. Create a vec which holds the exact same amount of elements as in the array A. Isn't it like... Isn't that a thing? With the macro. Oh, that's right, there is a vector macro. It's like vec, right? With the macro wrap. I think I still have to... That just takes elements, right? So that's... like I32, right? It's like, it's type and then elements. No. It's just elements. There we go. Right, it does type inference. Back to... A vec of even numbers is given is to complete the loop so that each number in the vec is multiplied by 2 and return a new vec. Right? So let's see. Right, this is going to be it's like E dot push in this case. I think I want to do it because I want to be able to oh right, let's call this out instead. So that's a mutable reference to an I32, and that's an integer. Okay. This needs to be the value of it then. Do the same thing about using mutating the vec. Let's return it. Oh, I'm supposed to mutate the... Oh, I'm supposed to mutate the vector. That's different. So you have v dot... I think that works. The value of element is equal to its value times 2. So now it should just be... Yeah. Hate that, but that's way nicer. Right. Well, I gotta figure out why am I not getting I'm not getting very good, like, IntelliSense for some reason. Yeah. Like, this feels very wrong, because that's like a mutable iterator and... Ugh. Move semantics. All right, this is where we're getting into stuff that I'm not very confident in. On line 20. Vec.push 88. Cannot borrow vec as mutable because it's not declared as mutable. And I need to make it mutable here. There we go. Okay. Hold on, let me actually pull up this. So that makes sense. I'm just like, I get the concepts. I'm not super clear on the syntax of like the syntax difference between moving and borrowing. Right, like I remember the mutable references and all that. That has a reference to an object as a parameter instead of taking ownership of the value. Okay, so if you just pass it, it now owns it. So like in this case, this vector was moved to this function. So then couldn't I also then do this? Yeah. So that works just as well. Yeah, that's what I'm used to, is the ampersand as a reference. So I guess that's really the big difference then. Yeah, I guess that's the big difference, is that when you move it, when you pass something without a reference, you are moving it to that function. Yeah, because well, I guess, yeah, so I guess you can't, you're never passing by value, you're either passing ownership or you're passing a reference. Like, it doesn't seem like there's very often that you pass by, like, there is no, like, pass on copy or pass on value. Like, it's all either, like, there is one place where this thing lives in memory. You can either give it to the function if you're done with it, or you can let it borrow it for a minute and then do it. Yeah. You're basically telling it that it, at the end of whatever scope I just moved it to, is the end of the lifetime. Semantics 2. By finding a way to keep both vecs separate. So vec0, mute vec1. Right, so this doesn't need to be mutable. I could give it a clone. And that feels like, right, because I'm copying it. I'm giving this a copy of that memory to move. So like there's this thing in memory, and then I basically copy this memory in the heap, and then give ownership of that copy to this function. Okay. That's starting to make sense. Without adding new lines, just changing existing lines. No lines with multiple semicolons necessary. So there's this. Right, this doesn't need to be mutable. First of all. Cannot borrow as mutable. So I think I could do... Is that the syntax? Yeah, I'm going to be streaming. I usually stream every Wednesday, and then I try to do one other day during the week. But Wednesday, I always stream from like 6 p.m. EST, basically until I hit a stopping point. Pretty much doing random stuff like, you know, learning new languages, working on projects, whatever it is. Yeah, really, really happy you got to found it and you enjoyed it. Okay, that I don't think is the solution they were going for. It does feel like I kinda have to. Hold on. Pull this up real quick. Right, immutable reference like that. So if I have a, if I'm passing it as a, some mutable reference to a vector, right? I need to make sure this is mutable. And then I should be able to pass mismatch types dot to vec. Oh, I see. When it gets down here, it can't. Okay. So, right, so I created a mutable vector. I passed a mutable reference to that function. It pushed a value onto that mutable vector and then returned I guess a copy of it? I think that's what that did. Not 100% sure, but that feels right. That feels right. Yeah, I think so too. Because I don't think I didn't return, because that's what I was saying, is I couldn't return a reference to it. I guess that's the other thing I could have done, is I could have just said this is a, you know, a reference to a vector. Or a mutable reference to a vector, but I can mess around with that later. So that instead of passing vec0 into the fillVec function, the vector gets created in the function itself and then passed back to the main function. Okay. Right, so if I do this, I'm moving the result back out. So then I should be able to say let vec equal this. No longer takes an argument. Don't change this. Let's create and fill the vec in here. Alright, so this is no longer needed. Let this mutable vector that. Yeah, okay. Because then I'm moving this vector out here, it picks it up and then does this assert equal, so this line is no longer necessary. Perfect. Okay. Make me compile by reordering the lines in main, but without adding, changing, or removing any of them. Okay. Cannot borrow mutable more than once. Right, so I have a mutable x, let y. Yeah. Right, 100, take the value at y, at 100, at... Okay, because this now goes up to scope. Got it. Can't change anything except for adding and removing references. Okay. Move occurs because data has type string, which does not implement the copy trait. Value is moved here. right? It gets moved to here. Should not take ownership, so this should instead be a reference and a reference, right? Temporary value dropped while borrowed, and this should take ownership. So this should just be past the string. This, all right, that should have stayed. Cool. Okay, so I can declare that the function parameters are also. Yeah, I wasn't supposed to remove that mute. Yeah. Okay, interesting. What's next? I'll probably get through. Let's see how many are structs. I'll do struct. I'll probably do structs in one more module, and then I'll be done streaming for the night. It's been almost 2 hours now, and I still have to eat dinner and, you know, be an adult for a little bit. But I do really like this. I think I'm gonna try to stream again on Friday and try to finish this up and see if we can do a project with it. So let's see. Address all the to-dos. Something goes here. Something goes here. Instantiate a tuple obstruct. Initiate a unit-like struct. Okay, so for the tuple struct, it looks like it's 3 integers. That's what I32, I32, I32. And then green equals color tuple struct 0, 2, 55, 0. Struct unit like struct? I mean, do I just... Yeah. Let's see. Yeah, it seems like... I don't think putting mute in the function parameter is common. Based on everything that I've seen about Rust so far, it feels like you're definitely not supposed to do that. I guess if you take ownership of it, it's not that bad. But actually, hold on. I want to see that one more time. Yeah, because this is a string. So it took ownership of it. It took ownership of it and then made it mutable while taking ownership of it, which feels very, very weird. Damn. Not sure about that one. I guess. Yeah, we'll say like it should be like red I32, right? And then this one should be color classic struct. I misspelled green. There we go. Okay, so that's pretty straightforward. I'm not sure what this is for. Like, I don't know what this Unix-like struct is for. Like, do they give an example of, like, what it's for? Unit. You define structs that don't have any fields because they behave similarly to nothing. You need to implement a trait on some type, but don't have any data that you want to store in the type itself. Okay. So yeah, it's a type that doesn't have any data. Okay. I mean, couldn't you also just... I don't know, it feels like very unnecessary to have this when I could also just do that. You know what I mean? Like, that feels like exactly the same thing. Yeah. So I don't understand why you need that syntactic sugar for that. Maybe it behaves differently, I don't know. That just feels very unnecessary. Alright. I guess, but like you can't store any data in it, so I'm not sure what you're even, you know, returning. I guess like the Java equivalent of it would be like a class that only has, it has no internal parameters and only has static methods. Like that's the only thing I can really compare it to. Is it's just a collection of trait types, I guess. Address all the to-dos. Where are the to-dos? Create your own order using the update syntax and the template above. Okay. The update syntax. Yeah. And I think even if that's what you wanted to do, you could just make a normal struct that just doesn't have any data types on it. Like I don't get why you need a special syntax for that, but update syntax. Okay. That's kind of interesting. So let order equal create order template. Oh, that is the, oh, I already did that. So is order template. Is that first? Needs to be string from, is it 2 dot? Oh, it's 2 dots. Alright. Was that really? You couldn't do 3 like every other like expansion operator in the world? That feels like it's intentional. That's like intentionally done to make it more difficult. Contain data, but also have logic. Package tracking, want to test some logic attached to it. Make the code compile. Okay. Okay. So this is how you should handle errors in Rust. Oh, it's not how you should handle it, but we'll get back to that later. Cool. So is international. I guess this should return a bool. And then return send self. It's really annoying me that I don't have like autocomplete or anything. Yeah. I would expect 3 dots to be used as well, because that's like the spread operator for, you know, forever. Oh. So then get fees. Yeah, I don't think so either. Yeah. I'm very happy that they just went with 1 and didn't decide like, oh, for this will be 3, this will be 2, and everyone will really enjoy that. Let's just multiply the grams by 3. Self dot weight in grams times 3 turns a U32. One pass, 3 failed. Oh god. The bad part is I'm pretty sure somebody's done that. Like an inline with there's some macro that's like an inline brainfuck interpreter. I bet you that's a thing. So let's see. I did not like. Is that? Oh. Successes, failures. Online 86. Oh, it's supposed to be time cents per gram. Reading would really help me get through these. Alright, let's see which one's this. Enums. Alright, yeah. Probably after enums, I'll be good for today. And I'll come back to this. I'll try to stream on Friday. So let's see. Find the types of messages. I do need a refresher on how the hell enums work. Okay. That's pretty easy. Move. Oh yeah, this has been going pretty fast. I actually really love using enums. They make everything so much nicer. Like enums plus pattern matching is just beautiful. So let's see. Find the different variants. Ah. So move. Hey, thanks for the follow. There's some other way of doing, yeah, this thing. Okay, so you can just inline this stuff. X, I32, Y, I32. Quit, could just be nothing. Message. Oh, right, that is a message. So yeah, echo is takes in a string and then change color takes an I32, I32, I32. Yeah, cool. I am so glad that actually works. Alright, address all the to-dos based on their usage below. Where's message used? Create a match expression to process different message variants. When passing tuples a function, you'll need to use extra parentheses. Right, so there's change, echo, move, quit. So quit is that. Right, change then the color, echo, all that stuff, it's all the same. So, I think I can just literally just copy this from over here. It should be the exact same stuff. Oh, move takes in a point now, not that. Right, so now it's just these are failing. So state.process all these things. So match message. So then if there's a message move, right? That's how this. I gotta remember the match control flow. Okay, it is not that, it's this arrow. It should be self move position. So in this case, move is going to have point P, right? And then I don't have all of them, right? Message, echo, M. self.echo m. Message. What's the next one? Alright, change color. Can I do, I guess I need to do RGB self dot change color, a tuple RGB. Then I have to do the last one. Self.quit. So these need to be U8s, not I32s. Right? Self. Perfect. Okay. That's pretty cool. Alright, and with that, we got enums done, a little over 30, a little over a third done. I think I'm gonna call it there yet. So yeah, really appreciate everyone coming and hanging out and watching me learn Rust and helping out with the tips and everything. Yeah, and I'll see you guys probably on Friday. I think I'm gonna be streaming again on Friday. Alright, have a good night, everybody.